How do you feel, Karthik? I keep pushing you every day, pretty much, to study. Do you feel a little better for it?
It's all good, man.
Awesome. Awesome. I'm just teasing.
What did you guys decide? Like, how are we doing the format? I thought like last time we were discussing. You talk too much.
Oh, for the study group for this one, system design. Yeah. I'm okay with splitting it up. So what should we do? There was an old technique in kindergarten I remember called popcorn, where like I read a passage, then I say popcorn, and then somebody else, I pick their name, and then they start reading or they start explaining. So can we do that?
Maybe it helps to kind of just to keep ourselves committed, right? It probably helps at least two of us to pick some chapter or some topic, and then in case one is not able to attend, right, at least the other should kind of start explaining instead of reading the book.
Yes.
It becomes difficult to, for me at least, to attend these meetings during this time every time. So I would suggest maybe two of them can pick in case one person is not there, right? The other person, I mean, what I'm suggesting basically is like whoever volunteers to pick, right, they will go ahead and try to present a short summary of that topic, plus they will add notes onto the Notion link. So that will probably be effective, and it will kind of help both the participants and the person who picked to read. I mean, because the one who's explaining, right, they will probably get to know if they've really understood by the questions the participants raise, and everybody gets a turn kind. So that will probably be far more effective. That's what I feel.
Yeah, definitely.
Yeah, I agree. So basically, we should kind of take turns. Not this time, not me, because I didn't come prepared to this meeting. Next meeting, I'll come prepared. Promise.
Yeah, that's what. Even I am not prepared this meeting, but then that's why I wanted to kind of reiterate on at least two of us committing to it, because it becomes difficult.
Yeah, so this time maybe so you, apart from you and Karthik, you need to talk this meeting. I don't know if Karthik is busy with the kid stuff.
Yeah, morning is always like little crazy for me. That's why I'm generally silent.
Okay, so back to you, Vijay. Then next class we will be better prepared. We will do better job.
Okay. Hey, we have some more people coming in, so we could probably ask some other people here to jump in as well. I'm fine. Like I said, I can do this. I try to do this, even though I get tired, even though I get, kind of like, oh, maybe like I have a thought like, oh, I don't want to do this today. I just kind of remember, right, like the goal, right? Like goal is like much more important. So I think like for us, I'll have to just kind of internally think about that, and that's what just drives me to keep doing it. So
I missed the last meeting. So so we covered the transaction. So we are at the transaction processing.
That's correct.
Okay.
So I'll probably do the popcorn thing. I think that's like simple enough. And each person can kind of try to explain their part or read through it. And then, we'll just see how that goes. I mean, it is a study group. Nobody is expecting you to make a professional YouTube video here. It's basically just us like trying to understand, the contents of this book, as well as prepare for system design. So we can do whatever we want, in these groups. It's not a rigid format. Same thing with the data structures and algorithms. The only reason I record these is because I know a lot of people can't attend. That's really it. But if I was to make a professional YouTube video or a Udemy video, I would completely take a different format, right? I definitely wouldn't read from a book. I'd probably be very prepared. But that's Yeah.
Can we just 5-minute recap of Bloom filters and what are good stuff we missed? Can someone recap it for us?
Yeah.
Sure.
Let me get the Notion link. So 1 second. Okay, so here is the note about Bloom filter right here, actually. Okay, so let's see, Akanksha or Amolia, who wants to review this?
I can I can just go over it. I won't go. Okay.
Yeah, you don't have to go deep. Just
Yeah.
missed last class, so I'll.
Okay. So Bloom filter is nothing but it's a probabilistic data structure. Why we call this data structure probabilistic is because when in the underlining how it works is there are hash functions that are used. Now, in this example that you see in this Notion link, there are 3 hash functions they are trying to use, and they are trying to, you see if they're in the example, they are trying to hash a word geeks, and they are trying to pass the word geeks through 3 different hash functions, and they have done a modulo of 10. They have done a modulo of 10 because it is a 10-bit array that they have used. And when they modulo 10, they get 1, 4, and 7. And at location 1, 4, and 7, they are converting 0 to 1. Initially, when the bit array is initialized, it is initialized to all zeros. And when you start using hash functions and you start passing values to it, whatever locations you get, those are the locations that are targeting to this bit array. Now, coming back to the second example. So first example was geeks. Then the second example is of nerd. Again, we get position 354, right? And we change the zeros to 1. Looks good. We pass cat now in the third example and we do a modulo of 10 and we get 1, 3, and 7 again. But sorry, here they are trying to check. Suppose we want to check whether the word cat is present or not. So you remember, Amulya, you mentioned that Bloom filters are used to do a lookup. So this is what they're trying to say here. Yeah. So cat is present or not. So we will calculate the hashes using, again, we'll pass cat in those 3 hash functions, and you get locations 1, 3, and 7. But you remember that 1 and 4 and 7 was already we saw that we got those locations in geeks, and we got 3 in 3 in nerd. Yeah. And we never stored cat, right? We only stored geeks and nerd. So what happens is, so because bit set calculated indices are already set by some other item, Bloom filter is claiming that cat is present and generating a false positive result. If you can go a little down. Okay. So because the bits are already set by some other item, Bloom, so bits, as you see that we are getting a false positive over here. So that is, what is it about? But suppose I pass the word Amulya here, and I'm trying to pass the word Amulya. It's not necessarily using 3 hash functions. To keep this simple, they have used 3 hash functions, but when you are implementing this data structure in real life, there are multiple hash functions, and the more the hash functions you use, the more stronger your Bloom filter is and the less false positives you get. And the bit array is also very big in real life, and so that is how it works. And suppose you pass the word Amulya and you get you get a 0 in one of the, suppose you get, for A you get 0 and for remaining you get 1. Because you got a 0 for A and for the remaining of the letters you got 1, that means you are getting 0 because it is not present, right? So that means the word Amulya is not stored in the bit array. So even if you get a single 0, you are sure it is not present. But for the word cat, we can say, "Ew, it might be present. We are not sure," and that is why it's called probabilistic.
Got it. Okay. Yeah. So basically, it is dependent on also how good your hash functions are, right? Like they should, if they kind of give colliding answers to a wide, like wide range of inputs, then also your Bloom filter, I guess then you get
Precisely.
more false positives
Right.
than
Correct.
otherwise. Yeah. So
Yeah.
okay. Yeah. Okay, makes sense. Thanks, Akanksha. Saved me so much effort, but yeah, got the gist of it. Yeah.
We use a similar probabilistic data structure in one of the streaming platforms we have. It's called Count-Min Sketch. It is similar to Bloom filters, but it keeps track of 2D count something. If somebody clicks on anything, you need to keep track of those events. So yeah, that's another probabilistic data structure similar to Bloom filter, but it's 2D instead of 1D.
What was that? What's the name?
I placed a link in the chat. Count-Min Sketch.
Yeah, thanks, Ramya.
Here it is. I pulled it up on our browser here, so you can take a look at it. Just out of curiosity, was it something that they invented at your company, or is it just something that they implemented?
They just implemented. It's an existing algorithm. Yeah.
Okay, cool. All right. Okay, so how do we feel? Do we want to continue going to the end of this chapter today?
Yeah, at least the next 1 or 2 pages, I think I have read it and I can quickly summarize. There's not much of it over there. Probably after that, if Vijay has read it, he can complete the chapter.
Okay, sounds good. Do you want a popcorn sadhana?
Right. So over here, right, the next section is relatively light. So they are just talking about Oltp and Olap systems. So we basically have 2 different kinds of systems. One is the Oltp, that's basically used for transaction processing, online transaction processing, or Olap, which is for online analytical processing, if I'm not wrong. So basically, you have transaction processing, which is done over a very small number of records, and you expect it to be like you have random access, and then you're expecting a very fast throughput, or you're expecting a very low latency writes from the user input. However, your OLAP is basically a system which will be used in the background by, say, some data analysts, where they will perform huge queries. They'll kind of do some aggregation over large number of records, and it is mainly used as a backend. It is not used in real time. So this is the major difference between an OLTP system and an online OLAP system, right? So data warehouse is nothing but a place where you go ahead and do all these online transaction processing, right? And if you go down, right, there is a diagram over there. So in this data warehouse, right, the whole process of cleaning the data and then kind of loading the data to make it available for any kind of analytical processing is called as ETL. So it's like you extract the data and then you load it, and then you transform the data into something which can be queried, and then you load it onto the data warehouse where the business analyst goes ahead and queries. So that's the main idea. And then if you go to the next page, right, they have this schema kind of a thing. So there is something called as star schema, and there is something called as a snowflake schema. So both of these are similar. So if you go to the next one, right, next page. So over here, you have something like, no, I want this diagram. So in this diagram, right, you basically, if you look at this diagram, there is something called as a fact sales table in between. And you have different tables, which are, you can map it as this is the primary key. So product _ SK is your primary key. And then you have foreign references to dimension product table. Similarly, for store SK, you have foreign references to dimension store table. So you have multiple of these things, right? If you just imagine this, if, okay, they have kind of condensed it, but if you can just expand the whole diagram and see it, right, it'll look like a star. Fact sales table being in between, and all the other tables, right, it kind of forms as a star. So that's why it is called as a star table. So this is the typical way by which the data will be arranged in any kind of an Olap system. And if you look at, if you just think a bit, right, you will see that the number of rows in your fact sales table is going to grow long. So that's where you kind of indicate, say, for example, here it could be like a product which is being sold at a certain store to a certain customer. So that's where it will continuously increase, but the number of products is going to remain kind of constant. And similarly, the number of stores also is going to kind of remain constant. So the other tables which are surrounding this fact tables are going to have a little less, I mean, it is going to have almost like constant data, or it is going to grow very slowly. Whereas your fact sales data, right, it's going to grow really fast. So and most of the queries will be done on your central table. So over here, they call the central table, I don't remember the name of this. Okay, the central table is always called as the fact table, and the surrounding tables are called as the dimension tables, right? And the difference between a star schema and a snowflake schema is something like, in your star schema, right, the number of what do you say, how you basically normalize the tables, right? Completely, okay, I always get confused between normalization and denormalization. So in your snowflake schema, it will be like you will not have duplicate data. So whatever that is, it's denormalized or normalized. I always get confused.
Oh, so that's normalized when
yeah,
you
normalized. Yeah. So in your snowflake schema, right, you will have most of them will be normalized. Whereas in your star schema, you can imagine it to be like a star only. So you will have fact sales table, and then you will have a number of, it will be normalized, but it won't be completely normalized. It won't go to the third normal form, for example. Right? That is one thing. And if you just if you just think about how the ways how the queries will be run, right, it is going to typically run in such a way that it's like from the fact sales table as well, right? You will basically kind of the analyst, how he tries to run is like, say for example, he will rarely run select star from a fact sales table. He will basically run only he'll try to pick only 4 or 5 columns at a time. So he requires only X number of columns to run his analytics. So in basically trying to take advantage of this query pattern, right, they have something called as a column oriented storage. So if you in a normal tables, right, you basically store it row wise. So it is like stored as a table as it is. But in a column oriented storage database, right, you will be storing it as a column. So for example, all the date keys will be stored separately, and then the product SK keys will be stored separately. Store SK keys will be stored separately. So it will be stored separately. So now if you start looking at that, right, the way they link it is the first row in your date key will be corresponding to your product SK. The first row in your product SK key. Similarly to the first row in your store SK key. So that's how, so they'll kind of extract all the first values from all the 3 columns kind. And the basic advantage of this is like the way they can store it is like they can go ahead and do some kind of compression. So Vijay, if you can just go to the next page, right? So they have something called as a column compression. So I didn't go too very deep into it. Did somebody say something? Okay. Come down. So here they've just given an example. See, if you see, they're just selecting certain number of columns. They rarely do select star. So how can we execute this query efficiently is the question over here, right? If you go down, right? So here, most of the next page, Vijay. So here, if you see, right, they're clearly mentioning all the values from one row are stored next to each other if it is a row-oriented table. But in column-oriented storage database, right, you will store it separately. So each column will be stored in a separate file. A query that needs to read and parse those columns that are used in that query. It can save a lot of work time. And so here, and in the last column, wherever Vijay has highlighted here, right, the column-oriented storage relies on each column file containing the rows in the same order. So thus, if you need to reassemble the entire row, you'll need to take the 23rd entry from the individual column files and put them together to form the 23rd row of the table. So the next, okay. So how can you take advantage of this fact is like they do something called as a column compression. So all the values, right, they can go ahead and compress it. So this is something which I did not go too very deep, but yeah, you can, I'll have to kind of recollect a bit to explain this part. Give me some time. Bitmap for each possible value. So yeah, so this is the product SK 69, 69, 69, 69, blah, blah, blah. So if you take if you calculate the bitmap for say 29, so it is like only the 29, only the value containing 29 is actually highlighted. I mean, it is marked as 1. Similarly for 30, if you see, can you just take your pointer on top, Vijay, where you can show product SK equal to 3011. Little more on top. Right. So that is product SK29, right? So if you just go down horizontally, you will see 1 only for 29. Similarly, right, that is only for 29 if you see on top, product SK value. So similarly, 30 is only for these two. Right. So the way in which you can encode this is like you can do run length encoding. So it will be like all these things. So for product SK equal to 29, right? It's going to be 9 zeros followed by 1 and the rest all zeros. Similarly, for 30, it is going to be whatever 10 zeros followed by 2 ones followed by the rest 0. So this way they actually save space. So that is one part. And okay, I'll have to go a little more deeper into it. So
so this column compression is applied to dimension tables, right?
Fact table.
Oh, you mean?
Maybe for, yeah, it should be for dimension tables, right?
Right, because you have a standardized code.
The values will be, the values are constant kind. I mean, rarely changing kind.
Yeah.
Yeah, and there is something called as column family versus column oriented. This is column oriented, but typically Cassandra uses something called as a column family. I always thought it was the same, but the author says no, they are not the same. So it is very easy to get confused. So maybe I can take an action item where I can kind of understand what is the difference between a column oriented storage and how does it differ from a column family. Right. So that is one part. So yeah, that's where I think I stopped reading. So maybe
so typically how this so in this Olap, like in this kind of databases, right? So the data, you have a primary database like a SQL or something that actually is serving customer traffic, but then you copy over this data into another Olap optimized solution. And optimize it for querying like this.
Right. So they have a copy of that original database. They rarely run the queries on the same database where OLTP transactions take place. The main reason being it will slow down. It's not going to be a low latency system kind. So you will be blocking your actual transactions.
Right. Okay. So this all happens at the time of copy over. So there must be some out of the box solutions that provide this bitmap encoding and column compression.
Right.
Okay. So it's pretty good. I wanted to just ask, like here, I got maybe a question from somebody. Do we want to just maybe like one time go through this once more and review the section? Was it too fast or was it just fine? I want to ask people here.
I just provided the gist. Yeah, we can always take a call whether we want to go through it line by line.
No, that's good actually. I think that's a good use of everyone's time, right?
Okay.
Yeah.
I mean, I guess like maybe just the points, I guess, are OLTP, OLAP, then you have stars and snowflakes. So just be able to explain the difference between OLTP, OLAP, this model here, what is a fact table, what is a dimension table, and then the things about what dimension tables represent, the who, what, where, and when, and why of the events. And then talk about like schemas, the star schema, as well as, if you're going to go into, column storage, explain how that works. How do we execute queries efficiently? And then basically kind of like the difference between like column storage and row oriented fashions, compression, which we just started to talk about, and bitmap encoding. And some of this gets a little complicated. So if you feel like you still need help understanding it, maybe a good exercise would be just to write to the notion, and we can have like another, session where we do like one-offs where we kind of represent some of these ideas.
Yeah, I mean, what I felt was that I don't have a clear distinct, understanding of what's the difference between star and snowflake schemas. So question is, so in practice, right? Like, let's say you want to do some analytics. So do these tools, like whatever this analytics tools, do they give you this option? Do you want to choose star or so, or like, is this something, the schema is like we follow this principles and design this whatever, columns or basically whatever optimizations that we need to make? Do we do that because we know the data better, or is it, how does it work? Like, I'm not I don't have the experience actually applying this knowledge.
I can add more to this.
Go ahead.
So I studied this in the data mining class, and I could easily follow what Sadhna was trying to tell. We also went ahead and in the class, we also went ahead and made our own, like here we talked about star schema and snowflake, but we discovered our own schemas, I would say. And like each group within our class had to give a pros and cons of the own newly discovered schemas they are trying to come up with. So to answer your question, the kind of problem you're trying to solve and what kind of queries you're trying to run, it's not necessary that you use the exactly same schema. You can modify beyond snowflake schema, and you can modify, and maybe you don't like something in snowflake schema and you think that this should not be there, or you want to add few more dimensions table on the existing dimension table, and maybe adding a dimension to a dimension. That's what Snowflake is also all about. And maybe adding a dimension to a fact. Maybe adding a fact to an existing dimension, something like that. So it gets very complicated in real life, but it's not exactly people just exactly implement what we are studying here. And that's what I studied in my data mining class.
Oh, okay. Okay. But what do you mean by dimension for a dimension?
Yeah. So what I mean is like on a just imagine this. You have a fact table in the center, and you have 4 stars. The 4 stars are your dimensions, right?
Uh-huh.
Yeah, exactly right. And now on this dimension, like on those 4 or 5 dimensions that you are seeing, just create one more line and add one more table to each of them. So there is a dimension related to a dimension, right? And it's trying to store some extra information about that dimension, right? So it is trying to store, yeah, exactly in the second one, yeah, something like this, right?
Kind of
So
normalizing it more.
yeah, normalizing it more, right? But you can even go beyond what is present in the Snowflake. You can even go beyond that, and you can modify it further. I mean, if I find out my slides, I'll present it next time maybe. And we did something similar actually. So
Okay. So basically the transition, you start with star schema and before you know it, it becomes Snowflake. That's what it sounds like.
yeah.
So you start with like some crude columns, the dimensions that you think you would be wanting to project, and then it becomes, you create more dimensions, and then at that point it becomes Snowflake.
Yes.
Okay.
I'll try to find out my slides, and we presented our own schema, but and then we had to present its pros and cons. Yeah, it was interesting.
I still see no way for me to easily turn off dark mode, and it's just annoying me. But okay, yeah, great explanation, Akanksha. I think that was very good, especially like just talking between the differences between stars and snowflakes and complexity. So I think we can kind of go back to here. I'm going to move out of the way. So at this point, I think like we can probably, and I'm going to move all this out of the way, the Zoom stuff. Okay. So I think we can continue on. So we were kind of like at column compression. Does anybody else want to popcorn? Sadhana, I'll give you the ability to do that if you want to call someone else.
Whoever has read it. I think it is only you, Vijay.
Okay, so you're gonna throw it back at me. All right, cool. That's fine. All right, so yeah, basically I'll just kind of go through this, right? So I'll tell you this, that like when I started reading this, I kind of started to get a little overwhelmed myself. So I just made a lot of highlights here. So it's probably good for me to just read like the highlights and maybe just kind of like piece together parts of it. So yeah, going back to the stuff about column compression, right? It's about efficiency. It's about making the the data like simpler to retrieve, and so that's why they use bitmap encoding. Bitmap encoding, we just went through an explanation here, but this is kind of like a diagram for bitmap encoding. I just wrote here or highlighted here, the number of distinct values in a column is small compared to the number of rows. For example, a retailer may have billions of sales of transactions, but only have 100,000 distinct products. So the bit is basically like the way they calculate the bit is you take a column with n distinct values and turn it into n separate bitmaps. One bitmap for each distinct value, essentially. A 1 if that row has a value and 0 if not. Again, kind of a little bit complicated, but here's like kind of some diagrams. As Sadhana was saying, if n is really small, then these bitmaps can be stored 1 bit per row, but if n is bigger, then there'll be a lot of zeros in the bitmaps, and we say that this is sparse. So here, this is how like they translate some of these queries. So where product SK is in 30, 68, 69. What we do is we load the 3 bitmaps for product SK 30, 68, and product SK 69, and calculate the bitwise OR of the 3 maps, which can be done very efficiently. Is anybody here not familiar with bitwise OR bit operations?
I was not aware of the run length encoded. You should underline that for yourself, because I mean the first level encoding we've done, we have done in our. I think it's a common technique. If you are working on authentication side of things, like where you do this claims like permission scopes and all, you want to embed all that in a token. So you kind of do this bitmap encoding. But we always like there are so like as we keep adding features, we run out of that bitmap, whatever that space that we are provided with. So run length encoding is probably something we should look at next.
Mm-hmm.
So this is
Correct.
encoding, second level of encoding. Mm-hmm.
Right. So here's another one. This one is load the bitmaps for product SK31, SK3. So this is an AND, this is an IN. So you do a bitwise AND operation. And again, like these are just, doing basically bits addition, bits ORing. If you remember like the beginnings of your computer science, like any lectures, 1 and 1 make 1, 1 or 0 can still be 1. So true or false. Basically, if you remember that stuff, true and true is true, but true and false is not true. That's kind of what's going on there. There are other various compression data schemes for different data, but again, we'll kind of skip that today. Cassandra and HBase have a concept of column families, which they inherited from Bigtable. But it's misleading to call them column-oriented within each column family. They all store columns from a row together along with a row key and do not use column compression. Thus, the Bigtable model is still mostly row-oriented. So just, again, kind of takeaways, columns, rows, and then be able to kind of talk about like what, these different technologies offer. Then we get into the section about memory bandwidth and vectorized processing. So a big bottleneck for big data is that it's getting data from the disk into memory. It's also about efficiently using the CPU cache, avoiding mispredictions and bubbles, making use of single instruction multi-data SIMD instructions in modern CPUs. So this is where, you have to really kind of get specialized with the way you handle data warehouses. It says, besides reducing the volume of data that needs to be loaded from disk, column-oriented storage layouts are also good for making efficient use of CPU cycles. The query engine can take a chunk of column compressed data that fits comfortably in CPU's L1 cache and iterate through it in a tight loop with no function calls. A CPU can execute a loop much faster than the code it requires at function calls and conditions for each record that is processed. So it's just some optimization, here for retrieving this data, especially when you start thinking at big level scale. Then you need more techniques like vectorized processing. There's also, let's see, this next section here is about essentially sorting. And let's see here, I just want to jump ahead just a little quickly. So let's see here. Writing, aggregation. These are just some techniques that are part of like saving data. So sorting, we kind of went through retrieval, compression, then CPU management, and now we're in sort of sorting. So let's go through this. in a column store, it doesn't matter where the order of the rows are stored. It's just easy to store them in order wherever they were inserted. Inserting a new row just means appending to each of the column files. However, we can choose to impose an order like we did with the SS tables previously and use that as an indexing mechanism. We can construct a row because we know that the kth item in one column belongs to the same row as the kth item in another column. So if data needs to be sorted an entire row at a time, even though it is stored by a column, the administrator of the database can choose which columns should be sorted using their knowledge of common queries. For example, if queries often target date ranges such as the last month, it might make sense to make date key the first sort key. The query optimizer can then scan only the rows from the last month, which will be much faster at scanning rows. So one way of just kind of like, handling some of the data for sorting. Another one would be if the date key is the first sort key, it might make sense for the product SK to be the second sort key for all sales of the same product that were on the day grouped together in storage. So this, again, I would just kind of go through a little bit complex here, but it's good to just kind of know like about the techniques for being able to sort.
So question. So basically you can have this column storage in either star schema, like however you decide to define your tables, right? Whether it is star or snowflake, right? Is that right?
Yes, you can. And so
it's another design choice, like orthogonal to whether it is star or snowflake, right?
Right.
Okay.
Right. And I invite you all to just like you did last time, which I really, really liked, just come up with, like take a piece from this chapter. And so like if we meet up next time, let's review that. I think that adds to the value of this study group where, like everyone gets to participate, which I think y'all are saying. So like maybe, one of us can take column compression, another person can take, like star versus snowflake or memory bandwidth and vectorized processing, and just give like a lightning talk. I would say like under a minute, doesn't need to be over long, and then just add to the notes. That would be like really helpful.
I don't know what happened last week. Actually, yeah. So, so you're saying just I'm basically the later part of the chapter I haven't read, but did you mean that we just take turns and talk through our understanding?
Oh yeah. So what I'm referring to specifically is just there was a talk that, wait, you weren't there? Was it last week? Was it?
It was last week.
Yeah, that was last week.
Okay. I could have sworn you were there. Maybe it was just Sadhana and Akansha then, but they did a good job of like going over Bloom filters and stuff like that. The notes that we were kind of looking at the beginning, they did a good job of doing Bloom filter, LSM tree, and compaction. So just maybe in the same way, like if we can add some more information about this particular section, that would be great.
Oh, so you added all this in the class?
No, it was added before.
Yeah, and then they presented on it.
Yeah, so I think that's good. I mean, taking notes is like invaluable addition to whatever we are doing. I think that's very nice. Yeah, but what was that you suggest we do now? So we are done with the chapter. That's awesome. So
pretty close, yeah. Like it's just sorting, writing, again, optimization techniques. And I feel like for us, like I could read it, but I feel like maybe if you all want to just kind of take an ownership of one thing in like each of this last section here, like writing or reading or sorting or aggregation, maybe just kind of explaining how this works, rather than just reading it dry. I think that would be kind of very helpful. I'll even like jump in and take one of these and like explain it. But I think like we're pretty much done with the chapter, so.
Yeah, I totally agree with what Vijay is saying, and I have seen in other study groups I have attended in past. This really adds value.
Yeah, yes. And that's what I want to really encourage, like with this group too, is I don't feel like it should just be me reading all the time. I don't think that is a good idea anyway. Because only then like I get like, and I don't even think I actually get a lot of value from that myself. Like I don't feel like I actually like become that much better. But I feel like if we kind of just take pieces and review together, it'll be great.
Yeah, the most value, like I think with the way Sadhana did, right? Like even though it was compact and we kind of it needs a lot of effort on like I'm sure Sadhana went through it and revised it, make sure that she got the understanding right before talking. So I think if we put that kind of effort, everybody benefits, including the person who's speaking. So yeah, I think going forward, maybe for the next, are we looking into starting next chapter, or do we want to take a design question?
Yeah, so here's what I think, and feel free to, comment on it, but like essentially, so the lightning talk aspect probably shouldn't, like, so there'll be days where we're just reading anyway, like, I don't think anyone will be prepared enough, but just assume that like towards like the midpoint and end of the chapter, we just like, hand select a couple people here to like maybe do some lightning talks, and so some of the days that we meet, it won't be just dry reading, it'll be like some review and people kind of doing the lightning talks, and asking questions, right? Because we want to like review the stuff. It's very dense, I won't kid you, right? Like when I started reading all this stuff here, like my eyes refused to like stay open. Like it was very difficult for me to like even like keep reading because like I was just like starting to fall asleep. So I mean, I highlighted and like I forced myself with a cup of tea to just keep going, but I can tell you I don't remember as much as, if I were to like talk to somebody about it, and do a presentation on it. So something in the back, to keep it interesting, keep it fun. And then of course, like having a system design question at the end of the chapter too would be great, like an exercise.
And yeah, just to go with the concepts, learning of these concepts as well, right? I'm not sure how many of you all got a chance to go through that PDF which I shared in the WhatsApp chat today. Can you bring that up, Vijay? Actually, if you look at that, right, that is supposed to be a consolidated list of all the LinkedIn posts that a person called as Alex Zhu typically posts. I'm pretty sure many of them would have heard about it. So he kind of goes ahead and posts on many topics. So he's gone ahead and consolidated each of these topics, and he has put it into a PDF. So it has small chunks of concepts which can be easily consumed. So maybe every class, right, one or two of this will add real huge value, I'm pretty sure.
Absolutely. I actually think I've met him, and he might be a LinkedIn connection. So maybe I can reach out to him and see if he wants to give a little intro speech at some point. It'd be kind of fun.
Yeah, I mean, what I'm trying to say is, in whatever we have, right, we could just pick, say, one or two questions, some concepts. Each of them is a separate concept, so nothing is interrelated kind. So we could just go over it as well. It is actually very, or probably something which is related to whatever we are reading currently. So the day we start reading, say for example, we go through the replication chapter. I'm pretty sure there are topics related to replication over here. Now,
Absolutely.
You want to look at the database. So what are database? What was the first question?
Yeah, I think we can go over that. If you just go up a bit, right? I think on top. I think there was a visual guide to choose the right database. So page number 20.
Did we
Okay.
do this already? I thought I saw this diagram somewhere. Okay.
Yeah, this was a post which I think Ramya or Akanksha, somebody shared it on WhatsApp. So it's the same person who has consolidated all his posts into a big PDF and he's sharing it.
Mm-hmm. So do you want to go to this diagram? So it says, when the data is structured and you want ACID transactions, then yeah, if you want ACID transactions, then you choose relational, right?
Yeah, so
and
asset
then
transaction also means OLTP. So it's like online. So
okay.
if it is an Olap system, we go through, I mean, we choose a columnar. So that's exactly what we read about it now, right?
Exactly. Yeah. This is kind of like your flow chart. Here's the use case. Say I want an ACID transaction, Oltp or Olap analytical transaction. The thing though that I think that, like, because they said in the chapter, Olap is meant more for business people. You have to assume that that business person you're working with understands what Olap means, or like, the advantages of Olap versus OLTP, because I think this is more just very technical, right? Without a lot of deep dive into these things, you wouldn't probably know. So I guess this is just, anyway, like, for us who do know, we would say, okay, here, this is what this looks like, and here are the cloud providers or the big business providers of these technologies. These are what you have for relational. Here's what you have for columnar analytics. And then these are others like key values, dictionaries, right? So DynamoDB, Bigtable, Redis, 2D key value, entity relationships, JSON, so DocumentDB, MongoDB, use
Interesting that
case.
Same Bigtable and DynamoDB in the same category, because I thought, isn't Bigtable the same thing as, I think I'm getting confused with, so Hadoop and all is not Bigtable, is it? It's some different database. Okay. There's a database called Bigtable, that's Google. Okay.
Yeah, Hadoop is Google, I think.
No, they're saying if you do the dictionary kind of lookups, the counterpart for DynamoDB would be Bigtable, and Redis. So, but like DynamoDB is not meant for big data or like it's not designed for.
No, I think Bigtable is, it seems to be doing a lot of things. So it is under, what do you say, key value dictionary, it is under wide column store, it is under time series as well. It is under location and geo entities, geospatial database as well. It is under GraphDB as well. So Bigtable is probably a big umbrella of, so that's probably not the right example to pick. Probably something else.
Yeah, I can see how DynamoDB and Redis fall in the same bucket. Yeah, so both are kind of they're key value stores. Elastic cache and okay, so that's in memory. I don't know what the other 2D key values. 2D key values are what is the use case for a 2D key value? Does anybody know an example where you would want to use a 2D key value?
I think
geospatial is probably one of 2D key value. I might be wrong.
Is it something like when they say 2D key value, does it mean 2 columns forming a primary key? Is that what they are mentioning by
the key is a tuple or two entities.
Two of the columns form a.
Oh, is that what they mean? Then DynamoDB also supports 2D key value.
Yeah, I'm just looking it up here. 2D key value database. So wide column databases, I guess here's an article. It's a type of NoSQL database.
Okay, so they are telling it's a two-dimensional key store value where the first key is used as the row identifier and the second is used as the column identifier. So
Right.
First key is the row identifier.
Here, I'll
Correct.
put a link in the chat.
Okay.
It says, why did we come up with wide column databases? Why couldn't we just stick with key and value in relational databases? Back in the Stone Ages, we had the pain points. Relational model lacked flexibility due to its schema and structure, resulting in a lack of data compression. Key value store had a lack of structure that prevented partial write queries. And i.e. update column value, add column. Key value stores cannot filter data by value. Wide column data.
On the other link, it has a nice diagram which we can easily relate to it.
The other link?
Yeah,
which
I
one?
just pasted the link. Here.
Same page? Okay.
Oh, same page, you went below. Okay. I wanted to go through this diagram.
Okay, yeah, so go ahead. Do you want me to go through it or do you want to go through it?
No, I just opened this page and just try to read what was there. So it is like, it's a key value thing. So key and value. So in a 2D column, right, 2D DB, whatever you call it, the value is actually again split into column value, column value, column value.
Mm-hmm. Okay,
Right, so
it's basically to kind of handle collisions kind of stuff, right? So if you have multiple values associated with a key, then you would want to further optimize lookup within that key. So that's why you have 2D.
Not sure. Okay, maybe we can take this as an action item. One can just concentrate on only this diagram and try to understand what are the different kinds of DB and then present something in the next class or something like that.
Can we summarize what are we doing in the next class?
Yeah.
Yeah.
We had ideas.
Okay, so what we're going to be doing in the next class is essentially we're done with chapter 3. I think
but we still have to complete the notes.
Yeah,
I mean,
that's what I was about to say. Yeah. So you have to complete the notes.
I can take that. I can give me the weekend, like by Monday, you should have the chapter 3 notes updated. I can take that action item.
Right. So then let's all just kind of take points in this chapter. I guess we can just kind of volunteer by section to just go through and explain some of the final parts. So I can probably send out like, something in the chat that says, here are the topics, and then people can pick which one they want. And then we'll just have each person kind of like give like small talk or like a demo. You would do this anyway. If you were asked in an interview to explain something, you'd probably need to like know how to explain what something like vectorized processing is, or sort order, or all of this stuff, right? Or Oltp versus Olap. So just getting some notes on that. And then essentially we'll go from that to doing some kind of exercise that we can pick. And then from there, we'll go to chapter 4.
Is there a session on Friday? Because Friday I saw you have a DSA session blocked, or system design. Is it now once a week or twice a week?
Oh, no, we'll still be doing system design Wednesday and Friday at this time. Yeah. But usually like right after this, I try to do like a little bit of data structures and algorithms, although I'm just trying to finish like the whole like block for me, right? Like I want to get like the studying done 2 hours a day. So I always try to do that first thing in the morning. And then, I practice at night 2 hours. That's how I'm like happy with myself. But yeah, the data structures and algorithms thing is like Monday, Tuesday. And then we might just meet one other day instead of 5 days a week to give people a little bit of a break. So, yeah.
I can do chapter 4 reading and dissemination. I've read it long ago, so it's probably going back to my notes and figuring out what are the top points. Like Akansha summarized today. I can summarize. But when we start chapter 4, I can lead the discussion. Yeah.
Okay, sounds good. All right, well then I'll see everybody on Friday.
On the chapter 4, right? I think we should split up. I mean, if only one person takes majority of the, maybe yeah, for the starting Ramya next class, maybe you can do the next, probably the one after. Maybe one of us can take, and then that way we stay engaged, right?
Yeah, and I think you can do popcorn reading. I don't know if that works. Just kind of everybody read on their own, but then just kind of be ready to like at least talk a little bit about the chapter. So, and then if it gets complex, we'll break out into sections and we'll just discuss it like we did the previous week.
Yeah, let's see. I'm either way okay. So we can split 4 chapter, and like every day one of us take turns, or like one of us just takes up a chapter and does the lead entire time.
Sounds good. Okay. All right. Well, I'll see you all. I have to get to the next meeting, and then after that, finish out something. So thanks. I'll see you Friday.
Thank you. Bye.
Bye.